Hey everyone, today we're going to be going over the 2020 AIME 2 question 12. So let's get started. Let m and n be odd integers greater than 1. An m by n rectangle is made up of unit squares where the squares in the top row are numbered left to right with the integers 1 through n. Those in the second row are numbered left to right with the integers n plus 1 through 2n, and so on. Square 200 is in the top row, and square 2000 is in the bottom row. Find the number of ordered pairs m, n of odd integers greater than 1 with the property that, in the m by n rectangle, the line through the centers of squares 200 and 2000 intersects the interior of square 1099. So, the first thing you might be able to see after you might be able to notice right after reading the question is that the bounds on m and n are pretty specific because we have that square 200 must be in the top row and square 2000 must be in the bottom row. So if we draw a quick picture of what's happening here, we have an m by n rectangle where we have 200 somewhere and n. This is our n. Below here we have a n minus 1, 2, 2n, and this keeps going up until we have, I guess in this box we have m minus 1 times n plus 1, all the way up to mn, where m is the number of rows that we have. So on the right hand side we have all of our multiples of n. On the left hand side we have all of those multiples plus 1. And so the first thing, just by our initial picture here, and we also have that 2000 is somewhere over here. So the first thing we might be able to notice is that we can pretty easily find some bounds on n and m just by looking at the first and last rows. So from the first row here, we get that 1 is less than 200 is less than n. And remember that n and m are odd integers, which is why we can say that this bound is strict. Furthermore, we can do the same thing with the last row and say that m minus 1 times n plus 1 is less than 2000 is less than mn. And so the first thing we can do just by looking at these two inequalities is we can notice, well, we can multiply this one times m, and what happens when we do that is we get m is less than 200m is less than mn. So when we do this, it's immediately clear that m has to equal 1, 3, 5, 7, or 9, because if m is any greater than that, then we have a contradiction between these two. So that will not work. Well, I guess not necessarily those two, but just these two inequalities in general. M equals 11 just won't work. And so, well, we also know that m is greater than 1. From the original problem statement, we have m and n are odd integers greater than 1. So we've already narrowed it down so that m is one of the 4 of 3, 5, 7, or 9. So what we can do next is, well, we can try drawing a picture just to see what's happening. if we have m equals 3, we have a bunch of squares. We have a 200 here, and we have a 2000 here. We have a bunch of squares, and this is 3 rows. Well, the question is asking us to find the number of ordered pairs such that the line through the centers of the squares 200 and 2000 intersect the interior of 1099. But notice that when we draw these two, it must also pass through the middle of the square 1100, because 1100 is exactly in between those two. So we see that if the slope of the line is exactly 1, then it will cut the corners of 1100. But if the absolute value of the slope of the line is less than 1, then let's say for example, our boxes are over here, and there's like another box in between. Then our line will cut through 1099, which is what we want. Because this is what I mean. So ultimately, we want to find the number of ways to the number of pairs of mn which satisfy this. And so let's look at what happens in a general case. We have 1100. We're going to try to find the edge cases first, just to see what happens. And this is 2000. So let's say that this is our middle row, and there are k rows here and k rows here, and we know that everything is symmetrical because 11 has to be right in between 200 and 2000. Then we know that this box right here must be, let's call it x, and we know that x is equal to 200 plus k times n, because we know that there are n columns, and in between 200 and x there are k rows. So if we want the slope of this line to be less than 1, all we have to do is we have to say x minus k, which is this box here. We want this to be greater than 1100, because, well, if it's exactly equal to 1100, then we have this case, which is the case of drawn out, which we know doesn't work because the slope will be exactly equal to 1. But if the 200 is shifted over a little bit, then when we subtract k, the box will end up being greater than 1100, and we know we're okay. So that's what we're going to do. We want to set x minus k is greater than 1100. So we have that n is greater than 900 over k plus 1. And we can do the same thing on the other side. So this is in the case where we're saying our slope is less than 1. And if we do the same thing on the other side, just by looking at what happens when our slope is exactly negative 1, well, we have, in this case, we move x over here, that x is equal to 200, x is still equal to 200 plus kn in either case. But in this case, what we want is that x plus k is less than 1100. Because again, if it's exactly equal, then our slope will be exactly equal to negative 1, which isn't what we want. So we can do the same thing here. And we find that n is less than 900 over k minus 1 when we plug x into here. Okay, now it's now we have established bounds for n, and because we only have 4 cases for m, we can pretty easily bash our way to the answer. So let's start with, these are pretty important for us. Let's start with m equals 3. So when m equals 3, we have that k is equal to 1. Therefore, we have that n is greater than 901 and n is less than 899. Moreover, from our original bounds, we have here, we have that 2n plus 1 is less than 2000, is less than 3n. So we get that n is, so our lower bound will be 667. Our upper bound will be a little bit less than 1000, so 999. And so we just need to find all values of n which satisfy these sets of inequalities, which, if we remember that n is odd, is actually just everything except for 2 numbers. So we can find the number of odd numbers in this interval by subtracting 665 divided by 2. This is equal to 334 divided by 2. This is equal to 167. But remember that we need to subtract 901 and 899 for a total of 165 for when m equals 3. Now we move on when m equals 5. We sort of have the same bounds. In this case, k is equal to 2. Therefore, n is greater than 900 over 2 plus 1, so 451, and n is less than 449. We also have 4n plus 1 is less than 2000, less than 5n. So we have our lower bound at 400 and our upper bound at a little less than 500, so 499. And so we can do the same thing. The number of odd numbers in this interval is 50, but we're subtracting 451 and 449, so minus 2 equals 48 in this case. Next, we have m equals 7, in which k equals 3, and we have n is greater than 900 over 3 plus 1, which is 301, and n is less than 299. Moreover, we have 6n plus 1 is less than 2000, is less than 7n. So we have that. Okay, so this division is a little trickier, but we can handle it. Oops. So, we have 285, n is greater than that, so we want to have, this is our lower bound again, so we want n is greater than or equal to 286, and our upper bound will be a little bit less than 2,000 divided by 6. So, okay, so it's 333. It's 333 and 1/3, so when we subtract 1, it's still going to be 333, which is what we want. And yes, okay. So what we want is 333 minus 285 over 2 equals 15 plus 33, which is going to be 48 over 2 is 24. And we're subtracting these two numbers once again, so we subtract 2, we get 22. Okay, finally, m equals 9, we have k equals 4, and we get from here, we get n is greater than 226 and n is less than 224. And note that in this case, we're only excluding the number 225, so we don't have to subtract 2, we only subtract 1. And we have 8n plus 1 is less than 2,000 is less than 9n. So n is greater than, okay, I'm just going to take a peek. This is our bounds. And so, the number of possible n becomes, this is over 2, becomes 14. We subtract 1, we get 13. So our final answer is going to be the sum of all of our possibilities of n in each of the 4 cases. And so our final answer is going to be 165 plus 48 plus 22 plus 13 equals 248. And we are done.